Hey everyone, thanks for checking out my tutorial. So what we're going to make here is a way of navigating the AI using waypoints. Um, as the pathfinding system that's already in place is good, but sometimes you might want a little more control because just to look at it right now, what I set up, you can see him moving and you might not want him to take the absolute best path because that's what he's doing right now. You can see he's hugging the walls as he gets close. So he gets the best path. So I'm actually working on a little tower defense game, and I kind of want the enemies to run in a straight line. Like when he gets here, I want him to run here, and then run down here in a straight line, and then get here, and then turn, and so on. So that's what we're going to do. We're going to do that all in C++. You can certainly do it in Blueprints. In fact, I think this is one of the things that it's a lot easier in Blueprints. That's not to say you shouldn't do it in C++. I think this will be a good learning exercise. We're going to work with 3 C++ classes. I think ideally you actually want to use 2, but I want to use 3 to kind of show how you can communicate between the C++ classes. So as you notice, I just created a third-person C++ project before I started this video. So just go ahead and do the same thing. Just name it whatever you want. I think I named it like AI tutorial. And then I kind of just laid out the level a little. I deleted all the default objects that were here. I created a little viewing point for our character. Don't worry about adding this guy in. We're actually going to delete him and recreate him in C++. And then I just took some cubes, scaled them out to create kind of a little maze for him. So if we move this, he'll actually run right through there and take the best path. And then just one last little thing you need. How does he know how to run like that? So there is a volume. It's very nice. It's very impressive what Epic has. I moved the wrong thing there. Let's get that back in place. This over here. This right here. So one last thing you need is the nav mesh bounds volume. This is how the AI actually knows how to move. So if you press P you can see the green area is where he can run. And it's really nice. So if you take like this viewing platform and you move it, you can see it just automatically generates the new volume. Really nice. So that's about all you should need. Just make sure you press P, move your nav mesh volume into place. You can kind of see mine is right there. And just make sure you move it, get it surrounding the entire level, and press P, make sure it's all green. Kind of set it up a similar way what I have. You can put your character, don't necessarily need to do that. You can have this guy just on the floor, and you can still watch the AI move. But let's get started with some code. Because Visual Studio takes so long to prepare, I actually created the classes ahead of time. So what we're going to need is 3 classes. We're going to need an AI, a controller, and an actor. I will walk you through that, however. So we're going to go to Add New, C++ class. We're going to start with the Waypoint, which is an actor. It's actually a static mesh actor, so we can kind of see it. So just type in show all classes, search for static mesh actor, click next, name it Waypoint. And I would keep the names the same. It'll make it easier to follow the code. So that's going to be Waypoint. You'll click create class, wait for it to generate, maybe pause the video, and then when you're ready, you're going to make a new one, which is going to be a character. This will be the character that the AI possesses, which will be this. We're going to replace that blueprint guy with this character. So you don't need to show all classes, just choose character. I named this AI, enemy AI. Again, I'd keep the name the same as what I have. And the last one will be show all classes again, AI controller. Search for that. And we are going to choose AI controller. Enemy AI controller is what I created. So you're going to choose AI controller, next, and name it enemy AI controller. Okay, and then once that's all ready, I guess you can unpause the video and we'll get started with the code. Actually, first of all, I think what we're going to do is press P so we don't see that green. We're going to go ahead and assign the static mesh for the waypoint. So once you have that created, the static mesh actor, you can click on this, but you'll notice when you click on this, you don't have the option to select the static mesh here. And so you might think, if I drag it in, I add a static mesh, a cube, that'll be good to represent it. You might think that you can now drag it in again and you'll get another cube. That's not the case. So this is actually one point where you want to use blueprints. You want to right click on this, create blueprint class, and name it, I think a good convention is waypoint underscore BP. So whatever you named your C++ class underscore BP. Again, I've already created that. Actually, no, I haven't. So we'll do that. I should have created a blueprints folder. That's fine. We'll just put it at the top level, waypoint BP. We'll create that, and now in the editor, you can go to the static mesh component and just make it a cube. Maybe actually scale it a little, make it a little smaller. Don't really need to see that. So just do that, save that, and now you can drag this one in, and it'll always have that cube. Now, what you could do with the C++ class is actually in the code go point to that file directory, to that path, and say this is the mesh you want to use. I think that's a terrible idea. It's much easier to just create a blueprint derived class and assign the mesh there. Otherwise, if you do it in code, if you want to change it, you will need to change it in code and then recompile, which isn't exactly the fastest process. Anyways, kind of rambling there. So let's go to Visual Studio, and we're going to start with the waypoint. So we want to come to the header, and it's going to generate code for you. You'll want to just kind of ignore this, just don't delete it. This waypoint generated H, you're going to see this generated H for every class you create. It absolutely has to be there, and I believe it has to be at the bottom. So if you need to include some other header, make sure this one is still at the bottom. But let's get started. So what we're going to want to do is have a way of knowing which waypoint we want to travel to first. So we'll just create like a simple integer to track that. So let's just get started. This is going to be private. You won't need to access this outside the class. So we'll do int. What are we going to name this? I guess like waypoint order. And we are going to need a U property. So without going into too many details here, what this allows you to do is to kind of set some specifiers here that will allow you to change its value in the editor, among other things. So we're going to want edit anywhere, and this will allow you to change it in the editor. And then we also want a meta specifier, which I'll explain that in a second, but it's meta equals allow private access equals true. Make sure you wrap that in parentheses and then close off the parentheses here, and we're good there. Some of this might not make sense until we get to the end, so just keep following and this will all make sense why we have this and why we're about to make this function we're going to make. So we're going to make a public function that we want to be able to access it from other classes or instances of the class. So this is going to be public, and it's going to just return the waypoint order. So I think a good convention for that is get world, not get world, that's such a habit, get waypoint order. And doesn't take any parameters. We're just going to fetch this. So we need to implement this. So you can, if you hover over it, it just depends on the speed of your Visual Studio. You might not get that right away, but you can kind of drop down here, create implementation. That'll go to your source file, and we're simply just going to return waypoint order. And that is all we're going to need for the waypoint. So we are done here. We're actually going to come to the enemy AI next. So this is the character, the pawn. We're going to want something similar in here, which is going to be private again, and that's going to be current waypoint. So it's an int again. This is the waypoint he's running to, or should be running to right now. We're going to do the same thing. In fact, I'm just going to copy it. Actually, I hate when people do that because then you have to pause the video. So I'll type it out. So uProperty, edit anywhere, and then meta equals allow private access equals true. And now let's go ahead and build. And I'll try not to build too much during this because it takes some time. But I just want to show you that we can now set these in the editor. So if we look at the waypoint now, if we drag this out, you actually have a waypoint order now. So the way you'll do it, if you want him to run here first, like to the end of this path, we'll set, let's go ahead and delete this guy as well. This is the blueprint guy. We're not going to use him. And so we'll set the waypoint order. If you press end, it'll snap it down to the floor. And we'll set the waypoint order to 1. That's the first one we want to run to. And then we'll just get one more. Control C, Control V, copy and paste. And now let's change that to 2. And just really quick while I'm here, sorry about this, let me just move this guy back up to his viewing spot. You can also just press end here, he'll snap down to whatever's below him. It's a really convenient feature. So let's go ahead and save the level. And so now we have the 2 waypoints, so this is what we're going to run to. So if we come back to the enemy AI header, we are going to want to also, in the enemy AI, he needs to get a list of waypoints, an array of waypoints that are in the level. So we're going to do that using a T array. You should always use Epic's implementation of these types, like the array, rather than just using like a default C++ array. The T array performs a lot better with the engine. So this is going to be an array of references to actors called waypoints. And that again is private. And then we're going to make a public function, which you'll see why it's public here in a bit. But this is going to be moved to waypoints. Okay, so that's void, takes no parameters. And we'll go ahead and hover over this and create definition. And this is kind of annoying. I don't like that, how it opens in the same window. So we'll actually press Alt-O, which I think is actually a shortcut in Visual Assist. Just come to your source file, and now you have this function. But this is actually going to be the last thing we're going to implement. So I know we're hopping around a lot. It'll make sense. So what's going to happen is in move to waypoints, we're going to set up some code to move to a waypoint, move to whatever waypoint we need to move to. When that move finishes, we want to tell it to run this code again. How do we do that? So in the AI controller, if you hover over the base class and you press F12, you can go to its header, and we're looking for a function called onMoveCompleted. And you can tell based on the name on, it's kind of a convention, like when something happens on. So this is the signature. We're going to override this functionality. Now, really quick, if we come back into the editor and we look at this blueprint guy, so this is when I clicked play before, this is just what I set up. So this AI moved to, like, whenever you're trying to learn C++ with Unreal, it's always good if you're looking for like where something is, what class something comes from. If you simply right-click on one of these nodes, you can click Go to Code Definition. It'll show you the header file it's in, and then you could actually, Control F, get actor location, and there is it's kind of its signature. You could then view the source from there, but that's a whole nother subject. However, you'll notice that this AI move to, if we right-click, there is no Go to Code Definition. It still exists in code, and it's still got here from code, of course. But this AI move to is actually kind of a blueprint only function, which is why we have to re-implement it. And so this on success, that is what we just looked at. Where did it go? The on move completed. That would be this result contains the success and the failure. Anyway, what we're going to do is we're just going to copy this signature because we're going to override it. This keyword virtual means it can be overridden. You can give it your own functionality in your derived class. So in here, we're just going to paste that in, and then we're going to add override at the end. Okay, I actually don't think you need the virtual. My C++ skills are actually a little lacking. I think you would need virtual if you wanted to derive from this again, derive from a enemy I controller, and then you wanted to override it in the other derived class. I don't think it matters whether you leave it there or not. And then we'll just go ahead and define this. I'll leave this up for a second in case you just want to type it out instead of going to it like I did. If you're wondering how I found this, I would like to say I just looked through the controller and I found it, but instead I used the expert method of just Googling it. I was just Googled how to use AI Move 2 in C++, and I found this. So we'll go ahead and create the implementation. Now, we actually aren't going to use as parameters. You're required to keep them since you're overriding it. You need the same signature. In fact, the request ID, I don't even know what it is. The result contains if it's a success or a failure. I'm not going to use it because I know based on the way I have the level set up, it's always going to be a success. But what we're going to do here is, first thing we're going to do is we're going to get the AI, the actual character. To do that, we're going to do a enemy AI, a pointer, a reference to it, and we'll actually need to include that now. So include enemy AI.h, and we're going to cast to this. And I'll try to explain cast as best as I can. And so what are we casting? We're going to cast get controlled pawn. So this is going to return the pawn, the character. And the reason we need a cast is because the player controller, when you do get controlled pawn, it's going to get a type of a character, the class A character. But that's not what we're using. We're using a derived type of a character called enemy AI, the class we defined. So when you cast, you're essentially just saying treat this character we got as the class I defined. Okay? So anytime you do a cast, working with pointers in general, you always want to check them. So you can simply just wrap it and then an if check. And if enemy AI, basically it's saying if that's not null, then we will take that and move to waypoints. So again, let's just go over this again. So what's going to happen is this code we have here, that we will have here soon, it's going to find the current waypoint, move to it. Once that move's completed, this is going to fire. It's going to trigger automatically. And then we're going to just kind of recursively, it's not actually a recursive function, but you can kind of think of it that way. We're going to say move to waypoints again. So then we're going to come back here, repeat the process until we've moved through every waypoint. So essentially all we have left to do is fill in this function. We do need to do one thing, which is actually get a reference to the controller now in here in the enemy AI. So to do that, we will, let's see, we want to say a enemy AI controller. You could also do auto, but I think Epic actually discourages this. It's against their convention, their standards. Not sure why. I have no idea why there's a thing. I don't disagree with it. I don't agree with it. I don't know enough to have an opinion about it. But I just try to follow the standards they listed. So a enemy AI controller. It's going to be a pointer, and we'll just name this enemy AI controller without the A. And then we're going to cast again to a enemy AI controller, which we need to include the header for enemy AI controller.h. And what are we casting? The get controller. So this is just a function that the pawn has. It has get controller. Again, this will return an AI controller, or it'll return an AI controller. Or a player controller. It's going to return what actually possesses it. But regardless of what it gets, it's not going to be what we need, so we need to say treat that as our controller, the one we created. So now that we have that, we can start trying to find the waypoint. We did forget one thing, which is up here. We want to fill that array we made, the array of waypoints. Okay, so on begin play, we're going to do use a function in gameplay statics called get all actors of class, which is the same as if you go into blueprints and you say get all actors of class, and then you can actually go to code definition here. That should be in gameplay statics. So it's a really easy way. If you're working with blueprints a lot, you want to convert to C++, just do this. You can find out a lot of things just by doing that. So we know it's in gameplay statics. We're done with that. And what does this take? This takes, it needs the world. You can see right here, the world context object. So we're just going to get world. And then it needs the class you're looking for, so we're going to give it a static class. You can do that by saying a waypoint, which we'll need to include. It's just waypoint.h. A waypoint static class. There we go. And then the last one is the out actors, which you can see right here. So this is the array it's going to fill with the actors it finds. So this will be that array we made in the header waypoints. So that should be good. When the game starts, it's going to find all the waypoints, fill up waypoints array with it. And then I know one last thing we'll need to do here is when the game starts, we want to start moving to the waypoints. So we'll go ahead and call this right away, move to waypoints. Okay. And now we'll actually get the final bit of logic to actually move to the waypoints. This is going to get kind of messy. There's a lot of checks. It's going to get really branchy. But if you worked with blueprints, you'll see how much cleaner this looks than the spaghetti that comes with having a bunch of ifs and branches in blueprints. So first thing we're going to do is just check if that cast we did was successful. In fact, I can tell you this won't be successful unless you change something, which I think I already changed. So if you go to not this. Just like for the waypoint, we also need to create a blueprint-derived class of the enemy AI. So same convention, enemy AI BP. Create that at the top level. And And we'll fix this while we're here. So we need to just assign the mesh, which is going to be that mannequin. And the animation blueprint we'll use is the third person anim BP. You'll see right away he starts idling, his idle animation. And then this doesn't have to be perfect. Just kind of move him down into that. Maybe resize the capsule a bit. I think the template character, it's like 94 and like, I don't know, a little too fat there, I think. Yeah, and then just, like I said, this doesn't have to be perfect. His feet are kind of hanging out a little. That's fine. So that's good. And then what we'll need to do, though, is at the top level here, look at the AI controller. So this cast we're doing, we're saying we want the AI controller we created. So it's going to say if this guy is possessed by the enemy AI controller, but if you look here, he's not. He's possessed by the base AI controller. So we simply just need to change that to enemy AI controller. If you're spawning these guys in-game at runtime, which we won't in this tutorial, but if you ever do that, you would just need to change placed in world to placed in world or spawned. We just need placed in world. Okay, and let's go ahead and compile that, save, and now we can come back to the game and at our start point, you know, drop this guy in, and now you can also see that variable we set. So we actually want to set this to 1. So when it starts, he's going to move to waypoint 1. Okay, so let's go back to this. So if the enemy AI controller, if that cast is successful, which it will be now, we want to say if current waypoint is less than or equal to waypoints.num. So basically, this assumes that you're going to order the waypoints like 1, 2, 3, 4, 5. If you have 5 waypoints, it should be 1, 2, 3, 4, 5. So if your current waypoint is 6, then you're over the number of waypoints. You don't need to run the code under this. So the code under that is going to be a for loop to iterate through this array of waypoints. So we're going to use this ranged-based for loop, I think it's called, which looks something like, you could actually use, you know, like a normal for loop, like I less than waypoints.num, I++, but the range-based for loop is actually very convenient. So what it looks like is a actor reference waypoint, the current waypoint in waypoints. And then what you need to do, if you notice, this is a pointer to an actor. So what do we need to do? We need to cast. We need to cast, so a waypoint pointer again. This is something I kind of struggle with, is how do you name this? I just name it like waypoint iterator, ITR for iterator. So that equals cast a waypoint. And then what are we casting? We're casting this actor to an a waypoint. So the naming here might be a little confusing, but this waypoint is an actor because that's what this fills it up with, is actors, pointers to actors. So then you need to actually cast it to the type. And why do you need to cast it? Because the actor doesn't have the waypoint number that we gave it. So we're going to do another check under here right after we check this pointer. So if waypoint iterator, I'm just making sure that pointer is valid, and then yet another if statement in here. If the waypoint iterator get waypoint order. That's that function we defined at the very beginning. So if the waypoint order is equal to the current waypoint we're on, then we are going to use something from the controller. Not something that we define, just something that it's in the engine already. So enemy AI controller we want to move to actor. Okay, what actor are we moving to? We are going to move to the waypoint iterator. You could also just move to waypoint. It actually doesn't matter which one you type here, but to be consistent, we'll say waypoint iterator. There's a bunch of options here, parameters. Anytime you see there's an equal sign, it means there's a default value, and so you don't actually have to go through them all. I will set these first few like the acceptance radiance, so if we're within 5 units, we'll consider that move successful. And then this stop on overlap, which I think is bugged. If I set this to false, he's still going to stop on overlap. It's kind of annoying. There's a workaround to fix that. I'm not sure we're going to get to that in this tutorial. And anyway, so if we get to this point, then we're moving to the right actor and we want to break. There's no reason to check the other ones. So what happens here? So when the move finishes, it's going to go to this function we defined. So this is going to say on move completed. So as soon as the guy gets to the end, to the waypoint, it's going to run this same function. And so we actually need to, right here, current waypoint, we need to just increment that by 1. So then when it comes around again, the current waypoint is going to be 2. It's going to go through, then it's going to loop back to this, run it again, and it's just going to loop through until we've ran through all the waypoints. And I think that's about it. Just again, remember it starts off in begin play. We'll trigger this for the first time. And so let's go ahead and build, and hopefully I didn't make any mistakes. And it's good. So let's just double check that we have this guy, his first waypoint is set to 1. Okay, and then this one is 1. This one is 2. And then one more thing you'll want to do is you could hide these in game. I'm not going to here, but in a real game, obviously, you'd probably want to hide these little placeholders you have. But we actually want to come into this, and since we're not hiding it, since it is going to be there, we want to go to collision, and let's say no collision. And then if we click play, you can see the guy. That's really funny looking. And the reason for that is because if we go to the viewport, you just need to align this guy with that arrow. Okay, save, close out of that. Maybe we can rotate this guy when we start. And now you'll see you just run in a really clean way. And I didn't show this at the beginning, but the reason you might want to do this is because let's say that we just get rid of number 2, and we put this, like way over here. So what he's going to do, and this isn't like a bad thing necessarily, like it's just he's gonna find the absolute best route, and so he's gonna hug the wall. He's gonna rotate as he's running along with it. Looks kind of funny, but if you're making like a tower defense game, like tower defense games I've played, your guy's gonna run in a straight kind of a predefined path. You want him to come down here and then stop, and then so that's what this system is good for. So we can actually move this back, and let's make them go all the way around using these. Let's copy and paste, and then every time you copy and paste, just make sure you come and change that iterator or the waypoint order. Copy and paste again, and again, and again, and again, and again. Delete that little thing, not sure what that is. So this is going to be 3. This will be 4. This will be 5, 6, 7, 7, 8. Okay, and now if we play, he's going to take that really defined path based on the waypoints you created. What did I do wrong? 1. So this should be 2, not 3. And then that's, I think I got these all wrong. 3, 4, 5, 6, 7. Let's try that again. Oh, and one last thing. If you've made it this far, congrats. I know this is a long video. Sorry, I try to get through it as fast as I can while still explaining everything. But I just want to fix that snapping he's doing. Make it a more natural curve. So you can do that if you go to character of movement in the blueprint. And down here in rotation settings, orient rotation of movement, and then you can kind of change the rate at which he turns, let's say like 200 or so. And then save that, come to the top level, and use controller rotation yaw. We want to change that, turn it off. And now I think if you watch him turn, should be a more natural turn. Yeah, there we go. Yep, and then it'll just follow that nice path. So I'm actually making a tower defense game, and if you like this tutorial, I'm thinking about doing a full tutorial series with that tower defense game. So you'd actually have multiple enemies spawning. You could place turrets on these edges, and they would shoot the enemy. Anyway, thank you so much for watching. If you have any questions, let me know. I would appreciate any feedback. Hope I did a good job. Thanks again. Bye.